about DSP. Then we have talked about cohesion and coupling as well. Okay. So today we will see like how we are going to design a software and what are the strategies which is involved in designing a software. So whenever we are going for software design, basically it is a method to conceptualize whatever the requirement the software has into the implementation part. So we need to understand the requirement of the customer. We need to understand what are the resources that will be required. We need to understand what are the data structures, what are the functions, what are the platforms which will be, comfortable. So all these things is very much important to know. And software designing, it's a very challenging task because you have to design the entire product keeping in view the requirement of the client. So you have to see all the things that the client has to be comfortable. Okay, so that angle you need to check. So software design, when we say, it's nothing but a process which it's a process which basically conceptualizes the requirements of the client into the implementation. So when you do that, there are certain things that you need to keep in mind, like structured design. Okay, it has to be properly structured. The problem has to be well defined. The problem should be able to be divided so that every part or module of the problem can be solved. It can be conquered. Okay, so in that way, it needs to be done. Okay, so where a particular product or a particular software will have many, you can say, solution modules. Okay, so how they are arranged also, these modules in a hierarchy, how these modules communicate with one another also. So this kind of understanding we can have by two terms, that is cohesion and coupling. Okay, so when I say cohesion, before also we have said what is cohesion. It is nothing but it is a grouping. Okay, it's a kind of a clustering of all functionally elements which are related to one another. So that is basically we say as cohesion. However, when suppose you have two modules or three modules, if suppose some kind of message passing has to be done between one module to another, then that time we say that coupling is being taken place. So cohesion basically refers to the grouping of the likable or related elements. Coupling is basically communication or a message passing procedure that takes place between different modules. And whenever you need a good structured design, you need to see that the functionally related elements should be grouped together in a more strength. Okay, the reason behind is that since they are functionally related, since the features may be same, since the behavior might be same, okay, many things might be similar. So that cohesion concept has to be very much be prevalent in case of functionally related elements. Whereas if suppose for a dependency, the dependency among different modules should be lesser, because if the dependency factor is more, then what may happen, there might be some kind of error which might take place, okay, while message is being passed. So that's why they are saying that a good structured design always has high cohesion and low coupling arrangements. Okay. So in function oriented design, okay, so when we are now, that was the structure oriented approach. So in a function oriented approach, what happens? A big software is divided into smaller softwares or subsystems, okay, known as functions. This is because, when you divide any kind of a big system into smaller one, then each of the smaller units will be easy to solve, okay, and each of them will be performing a small significant task in the system. Okay, so in function oriented design, what happens is it takes some of the features of structured oriented design where you are taking divide and conquer method. Okay, so in this design mechanism, as we said, that it divides the whole system into smaller subsystems, which means that it provides an abstraction by hiding the information and operation. Okay, so in this kind of function-oriented design, basically it follows the principle of abstraction. It divides, no doubt, into smaller subunits, but then how these units are being implemented, that implementation is hidden from the user. Okay, it follows that very much. Another characteristic of functions in this kind is that when a program calls a function, the function will change the state of the program. State means the value which it returns, okay, which sometimes is not acceptable by other subsystems. Okay, so these are very theoretical. Then in object-oriented design, this you already are aware. So first is structured, where we are having the concept of cohesion and coupling. Then we had function. In function, what we are doing, we are dividing the bigger system into smaller subsystems. Okay, and then accordingly, we are trying to check whether there is a kind of a dependency among the subsystems, isn't it? In object-oriented design, however, basically the whole focus is around the entities and the characteristics, okay, instead of the functions which is used in the software system, okay. Certain things which is very much there in object oriented design, which you have seen in junior classes, also in object oriented, like concept which takes place like objects, classes, okay, then polymorphism, encapsulation, inheritance. Have you come across these terms before? Can anyone explain me what is an object, what is a class, what is polymorphism, what is inheritance? Can anyone tell me that? What is it all about? Anyone who can help me with this? So what is object? What is a class? What is polymorphism? What is inheritance? What is encapsulation? I think most of you must be acquainted with all these concepts, isn't it? You must have done in OOP.
Yes, sir.
So what is it? Anyone? What is an object basically? And what is a class? How they are related to one another? Yes? You have done or not these things before?
Yes, sir, we have done this.
Yes, someone was replying the answer. Who was it? Can you be loud?
Class is a object.
Yes, tell me.
Sir, am I audible?
Your voice is too low, Asif.
Class is a field of objects.
Anyone who can define what is a class, what is an object, what is inheritance, what is polymorphism? At least one each also, one else can define. These things I think you should be able, because in interviews also you'll be asked. These are basic concepts.
So object is basically the instance we can use. We can class is only but we can use the help of an object. And
Okay, so class is something like a blueprint, right? What Asif has said just now, isn't it? A
yes,
kind of a skeleton, okay, of what are the things that you might be having. So in class, what are the things that is there inside the class?
data members and member functions.
Okay, and what is an object then? How is object related to that class, particular class?
Uh, Even though class is enclosing data members and member functions, but we will be able to use that members and those members only with the help of an object. We can't use it directly. We need
Yes, so that where yes,
those.
yes, exactly. So basically, class is not, or sorry, object is nothing but an instance through which we can use or invoke, rather, I would say, the member functions and indirectly get access to the data members, isn't it? Then what is encapsulation? Anyone who can say? Anyone from the class? So many students are present. What is encapsulation? So many students are there.
Sir, using encapsulation, like data members can be hidden, so that
Yes, they can be made
using
as
the
private, isn't it?
public private, and in that way, like you like hide the data members.
Yes, what is the main reason that we encapsulate that from the outside world? What is the main reason?
Mm-hmm.
Sir, secure.
Yes, security aspect is one of the prime concern in case of OP. Yes, Asif has written something. Yes, very good. Okay, so then comes inheritance. So someone else can answer inheritance from the class. What is inheritance?
It is a class which can we can acquire properties from another method or field.
Okay, it acquires properties or features from a method or from a class.
Other class,
Features of okay. Then all right. How the data members or its features are being inherited from the parent class. I think you must be knowing there. Whenever we are following the concept of inheritance, then the from where the features are being inherited.
parent to child, class, then there are subclasses.
How features can be inherited basically, like what are the various modes of inheritance? What are the various modes? Can anyone tell me?
Sir, single, hybrid,
Like
multi-level,
No,
then
multiple.
that is the type of inheritance. But let's say, for example, if suppose one data member is being inherited in the next one, no, so there are certain access specifiers, isn't it?
yes,
The mode to which. So, what are the various access specifiers in case of
private,
inheritance?
protected, and public.
Okay, very good. So that's what you knew. Okay. So I need not explain. Then what is polymorphism? Anyone else? Polymorphism? You must have heard about polymorphism types like runtime and compile time polymorphism. So what is polymorphism? Anyone from the class? These are simple, basic, but and they will be asked only. What is polymorphism? Yes. What is polymorphism? Anyone? Arbaz? What is polymorphism?
Sir, polymorphism is an like ability to take like different forms of an object
Okay.
can take in different forms. So yeah.
Okay. So how does it explain different forms? How does it take? Like, can you give an example?
So sir, a class can inherit. I mean, a class can inherit the same function from different classes. So that way, let's say there's a function named a. So a, so
Okay.
that function can be inherited by the let's say class B from class A and class C. So that way,
But how then the things become different because they'll be using the same function, isn't it?
yes, sir.
And then what will be
The
different?
parameters.
Haha.
The parameters, the
No, that is something else concept. Actually, there are two things. One is what you are saying, that the same function name class would be using, but then the number of arguments, the return type will be different. Okay, like for example, add is there, three add functions are there. One of them is taking two parameters, one of them is taking three parameters, one of them is taking two, but one is integer, one is float. So all the three are doing the same kind of work, that is addition. But then at the arguments, their return type is different. So in this case, uh, we say that poly means it is inherit like exhibiting many features with the same name or okay in terms of function. So this is called basically your function overloading. This is also a part of polymorphism. Then one more, what Arbaz and Asif they were trying to say is this one, that yeah, maybe its subclasses, it will inherit it's some of the function. Okay, let's say for example we have a class called shape. Okay, now shapes will have, let's say, a function called area. Okay, which will compute the area. Now shape, when it will be let's say expanded in its subclass, so shape, from there we can derive what we can derive uh, let's say a rectangle, okay, then or sorry, a square, let's say for example. Then from square we can derive, let's say, a rhombus, isn't it, in that way? So each of the subclasses will have shape in each of the three. Now the difference only in each one of them is that each of the definition of that shape function will be different, because let's say when I find the area in case of rhombus, it will be half base into height, isn't it? That is how the computation will be done. Sorry, base into height only. Half base into height will be of triangle, so it will be base into altitude. In case of square, it will be returning side square, isn't it? So the name of the function which is taken from the parent classes, okay, or by the derived class, it is same, but the definition is different. That means what how we are defining inside the body, what value it will return. So that is different. Okay, so this concept is basically called overriding. Okay, which is used extensively in inheritance, and it is also called as runtime polymorphism. Runtime polymorphism because during the runtime or execution time, basically it will be decided out of all the, so like the function, like two of them are there in the derived classes, one is there in the parent class, but which one will be invoked, which of the function names are same, which one will be used. So that will be decided in the execution time. So that's why this is also called as a runtime polymorphism. Whereas in case of function overloading, what happens is basically for the same class, okay, we'll use three different functions with the same name. But in this case, what happens is the number of arguments will be different and the return type will be different. Return type may be same also, but basically we need to check first on the number of arguments, the data type of the argument. So according to that, the compiler will decide at the compile time which of the function will be invoked or called. Okay, so that basically it's called, that is the reason it is called your compile time polymorphism. Okay, so I think it makes sense. Is it clear?
Yes, sir.
So design process, top-down design, it's from the name itself, we can understand that maybe a system is composed of many, subsystems and many of the components. So in the top-down design process, what happens is the whole software system is taken as one entity, and then it is broken down or it is decomposed, okay, into several subsystems. Okay, then each of the subsystem or component is then treated as a system separately, and then it is decomposed further in the lower subunit where the decomposition is not possible at all. So slowly, as we have reached to the atomic level where the decomposition is not possible anymore further, then in that case, we need to conquer the problem. That means the subsystems one by one, and overall the whole like the problem can be uh, solved. Okay. Then bottom up is just the reverse. It basically proceeds with comprising higher level of components by using basic or lower level components. Okay. So what happens? First of all, it will start from the bottommost level of subsystem. Those will be solved. Then it will be combining the subsystems, moving for a higher level of component. Again, that will be resolved, and then finally the main system will be uh, achieved. This I have already spoke about data flow diagram, what are the types, but I have to do more examples. These are the definitions: entity, process, data storage, data flow. Okay. Why do we need DFD in a good software design? Data dictionary. I think with example also I have shown, right? Last time in the last class.
Yes, sir. Yeah.
The project topics, have you all formulated or not? The problem statement. These things I can skip because these are so. I'll be moving to unit 2 from next class, object modeling using UML. So we have 4 units. First unit I have completed today. Okay, so I will be giving some questions from first unit and one unit test also I'll be taking probably next week in Google Classroom. Okay, so like last time OS you have done, no? Time limit is given, and then accordingly you have to submit on time. So accordingly next week I'll be taking the first unit test for you all, and you have to prepare. And question papers, I think someone had already given me. I don't remember who sent me, but have received. Okay. So I'll do one thing that next week we'll have the first unit test for unit 1. I'll decide on the date. So for each unit, I will be taking unit tests. Okay, unit 1, unit 2, unit 3, and unit 4. All right. So at last, I will combine all these marks for the sessional test. I mean to say for the consolidated one. So you have to get minimum 50% in all these unit tests. Okay, because average I will be taking of all the four units. So that way it will help you to prepare for your exam also, because if every unit test is conducted, then you will be preparing, and I'll be strict. This last time I have given time limit of 12 hours, but this time the time limit will be of 2 hours only. So within that 2 hours you have to do, and Google Meet you have to install. Google Meet is already there, Google Classroom, and your face has to be visible while giving the test. Okay, and accordingly this will be a strict one. So I'll be giving the questions by tomorrow. Okay, so that way it will help you. Now maybe you have to study, you have to put in effort. Materials, have I shared with all of you the notes?
No, sir. Actually. Yeah.
No, sir.
Okay, okay, so I will share now.
Sir, for the exam, like, how will the exam be? Like, I mean, like, will it be will we like type the answers in like page, or like will we do it in a doc files?
Yeah, you have to type it in Google Classroom, like the how the boxes will be there. So there you have to type, and no, I think no need to type. You do one thing. You write in your answer sheet at home, and then that you have to scan and upload. That is much more meaningful. Okay. So that you have to do, and I think that will be good also, isn't it? Because typing may be a little bit worrisome. So two hours maximum will be there,
Okay. So like,
and
so like throughout the exam, we'll have to
yes.
like use the like being a Google Chat like meeting, na?
Google Meet has
That
to
you're
be
saying.
there and Google Classroom. So Google Meet, the faces have to be visible of all the students. They cannot go like they cannot hide the face. So accordingly, they will have to show, and within that 2 hours only, they have to submit. Because I came to know that all other places also they are doing in the same process. So we have to do in that way. It may be like little bit you need to put in more effort, but at the end of the day, by when you write the final paper in final exam, you'll be very happy that because we prepared unit wise, so ultimately there was no problem. Okay, so that will help you a lot actually in the final exam. Okay, any more questions? Anyone? Any questions? Let me I think I have to stop presenting.